So to calculate the dose, there's a number of ways we can do that, by either hitting this key here, is probably one of the quick ones, or as you can see the shortcut is F5. So if I hit F5, this will do our initial calculation, and the initial calculation just takes a few seconds, and then each additional calculation is quicker. So it should display our dose at this point. If it doesn't, then we just need to turn on the dose at this tick box here. Okay, and so this is our, what we would call our dose distribution displayed. So the first thing we do is going to set this up just to make it a bit more of a user friendly view. So if I go to planning, I'm going to click isodose levels, and the first thing I'm going to do is going to turn off these 3D isodose levels. So the 3D isodose levels are the isodoses that are shown in this view here, which are useful for some things, but not particularly useful for what we're going to be doing today. So untick that, click apply. They now disappear. And you can see here that we've got a number of isodoses displayed at 50%, 80%, 95, and the different colours they relate to. We can add extra levels if we wanted, or remove levels, and similarly you can make the lines thicker or thinner by typing in a number there. So I could do click 5 and that would make the lines ridiculously fat, and number 2 seems to be a pretty good happy medium there. So let's just go out of that, and if I open up this, maximise that now, let's just zoom in a little bit with that zoom, then we can see here the colours here relate to the isodose level here. Okay, so everything along this brown line is receiving 50% of the dose, and everything inside it is receiving more than 50%. Similarly, everything along this line is receiving 80% of the dose. Everything this side less than 80, everything this side more than 80. Okay, and we can scroll up and down. Remember that our dose distribution is in 3D there. Okay, so we can scroll up and down and see how much of the PTV is receiving which dose, and we get a good feeling for the plan through just doing that. Okay, so that's our dose distribution. It also tells us how many monitor units we need. So what this is telling us at to give 5 grey with a 12.1 field by a, where is it, 12.1 by 15.4 at 100 SSD. To give 5 grey to Dmax, we would need to give 490 monitor units. So what I want you to have a think about is, what would it be if it was a 10 by 10 field? So just hit pause, have a think about what that might be, and then we'll have a look at the answer in a second. Okay, so I'm going to change this to 10 by 10, and then I'm going to keep the SSD the same. I'm going to recalculate, and let's see what the answer is. If it comes up with an error, that's fine, we'll just close that for the moment. And we're expecting 500 monitor units. Okay, so the reason we're expecting 500 is our machines are calibrated at 10 by 10 field at 100 SSD, then 1 grey is equal to 100 monitor units. We've got 5 grey, so we've now got 500 monitor units. Okay, so I'm just going to move my view now to the central axis of the beam. Okay, and the way that we do that is by clicking on the plan, and then we're going to go to, in fact no we don't, we're going to click on the field, and we're going to do move the viewing plane to the isocenter entry point. Okay, so that's where the beam is entering the patient there, and then I'm just going to zoom in a little bit more here just around the beam. And what I'm going to do is, we talk about Dmax and we've looked at depth dose curves on the board in class. What I want to do is actually show you what it looks like on the planning system, to show you that it is the same thing. So this tool here, this dose profile tool, allows us to show the dose distribution. So I'm going to click on there, and I'm going to draw a line along my beam profile there, and we can see here that the beam builds up and then drops off. Okay, and we've got this little dink here So I wonder if you could think about what that is there. So let's just move this to here, and we can see on the line here, along the line there's that purple line, and that shows us that that's where the air in the rectum is, and we know that the dose can get attenuated on the within air, and so that represents that and shows us how accurate the algorithm is at calculating dose along that point. So I want you to have a go at is measuring Dmax along the beam and see what that shows us on this depth dose curve. So we know at 6 MV the Dmax is approximately the energy divided by 4, so we would expect it to be 1.5, and we might again just, depending on how accurate we can pop this line on here, but yeah, we can see there, can't we? And equally we can measure, we could work out these different points along here and calculate what they are. Okay, so let's go back to setting our field to the size that we actually want it to be in order to treat this patient. So I'm just going to go back to this view here, and because we've manually typed a field size in, it's defaulted back to a asymmetric field. So this is one of the few things actually in Eclipse which isn't the most user-friendly thing, but to be fair, most of the things are pretty user-friendly in Eclipse. So let's just make that asymmetric again. So remember, right-click on the field, go into geometry, and I'm going to make that a little bit bigger, like this. Okay, and then I'm going to calculate, and we'll have a look at how we optimize this in the next video.